Alright, so today is day 17. I didn't manage to do as much as I wanted because this week it's final exams, so after this week I will start again doing everything, doing 4, 5, 6 hours a day, but right now I cannot manage to do more than 2 because I have final exams. I have 6 hours of class and I have to study for final exams, so I don't have too much time for my own projects. But in this case, what I'm gonna start doing now, it's this project right now. I'm implementing the GPT tokenizer from scratch, and this is central in understanding LLMs because it is as important as optimizing the model, understanding the tokenizer, because the tokenizer is how you decompose the language to feed it into the model. And we saw that basically there are many different type of tokenizers that encode language in different ways. Yeah, and that's it. And we explore in this right now today. I just explore how how words are encoded and which protocols do we use, etc. Okay, I'm gonna just give a quick overview. So first of all, we know that given a string, we can understand a string as a concatenation of individual characters. And we know that each character has a unique identifier. And this unique identifier is determined by the Unicode. So we have a convention, which is like a dictionary that maps a character into a number. Okay, which this is the example. So we can always map a string, which is a set of characters, into a set of into a list of numbers. Okay, which is this is the example. All right. So we have the word hello. We can have these numbers. What else? Yeah. So Unicode is like the dictionary of mapping, but then we have the protocol because we need these numbers to occupy a certain amount of space. In which this case we use, which is the most common one, UTF-8, and this is encoding. So if we pass this text, which has 26 characters, if we encode it, sometimes it has more characters, mostly because some of the characters have a high number, and so the character, in order to be encoded, needs more bytes in space. That's the intuition. But the protocol, the actual protocol, I believe it's you have like 1 1 1 0 10 10. You have something like this: 10x 10 10xx. It's something like this. So it basically the first numbers tells you the character, how many bytes will it occupy. So if it occupies 4 bytes, it starts something like this, and if the byte that you're reading is a continuation byte, it starts with 10. So basically there is a way, where I'm saying that there is a way to map this number to split a character that doesn't fit in a byte into multiple bytes. And it's very useful to use this protocol because you can interrupt process and like you have every byte starts with an instruction. You can map the instruction, so you can know if it's a continuation byte. So you have extra information in every byte. That's why UTF-8 is very useful, also because it's regressive. Like it still supports like legacy encoding. All right. So that's basically it, and I was trying to start implementing the byte pair encoding, which is an algorithm that basically what it does, it's given a string, it's like a trade-off. It trades off the length of the size of the string by the increase on the vocabulary. So what it does, it's if you have a string like AAB, AC, it starts mapping the repeating pairs. You replace them by a new characters and do this process iteratively until you have a compressed pair of unique pairs, and that's it. So what I was doing is just first counting the most important characters, which is in this case is so for this given string, yeah, I count the amount of the pair that is the most repeated, and I'm gonna use this one to remove it from the string and add into the vocabulary like the mapping. Say I'm gonna create a new word and this is the mapping, and that's it, and I'm gonna replace it in the original string. So I just have to think about it and implement it. And for now that's it. And yeah, tomorrow I will probably, like in 2 days, it will take me to finish it because I'm pretty busy with the other stuff, but we'll see. All right.